Welcome to the DIY Honda Garage channel. This presentation focuses on the DTC code B12C5, which signifies an engine start-stop switch failure in the Honda Accord models from 2017 to 2023. The engine start-stop switch is a critical component located on the dashboard, usually near the steering wheel. Its primary role is to initiate the engine's ignition and stop the engine as per the driver's commands. When DTC B12C5 is triggered, it indicates that the switch is not functioning properly, which can lead to difficulties starting your vehicle. Accurately diagnosing and resolving this issue is vital for ensuring reliable engine performance. The following slides will delve into a detailed troubleshooting guide, covering the error description, possible causes, symptoms, and the steps to rectify this problem. The DTC B12C5 indicates a malfunction in the engine start-stop switch. This switch is responsible for starting or stopping the engine and is typically located on the vehicle's dashboard. Its functionality is crucial as it connects to various electronic systems, including the power control unit, to ensure proper engine operation. When this error code is present, it may suggest a failure in the switch's ability to send the appropriate signals for starting the engine, which can hinder the vehicle's operability. Its failure point can severely impact the driver's ability to operate the vehicle effectively, making the recognition and correction of this issue paramount. There are several possible causes for the B12C5 DTC. One common issue is a faulty engine start-stop switch, which may not function correctly due to internal failure. Another cause can be shorted wires within the electrical system, specifically the SS1+ and SS2- wires, which are crucial for the switch's operation. Additionally, open or high resistance in the wiring can lead to communication failure between the switch and the control units. Each of these causes can disrupt the electrical signals necessary for the switch to operate correctly, resulting in the detection of this trouble code and potential vehicle starting problems. When facing the B12C5 code, several symptoms may manifest. Most notably, the engine may fail to start, which is a direct consequence of the malfunctioning start-stop switch. The switch itself may become unresponsive when pressed, indicating that it is failing to deliver the necessary signals to the power control unit. Additionally, users may experience intermittent starting issues, where the engine starts successfully on some occasions while failing on others. Recognizing these symptoms early can aid in quicker diagnostics and repairs, preventing further complications and ensuring safe vehicle operation. The first troubleshooting step for DTC B12C5 involves using the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes. This is a crucial initial action that allows the technician to reset the system for accurate diagnosis. Following this, the technician should press the engine start-stop button at least 20 times consecutively. Then wait for a minimum of 20 seconds. This repetitive action can help ascertain whether the issue might be transient or connected directly to the switch itself. After performing this test, the technician should again check for DTCs using the HDS to see if B12C5 reappears. If the code remains active, it's likely a persistent issue, prompting further diagnosis. In the second step of troubleshooting DTC B12C5, the technician is required to turn the vehicle into the off-lock mode to ensure safety and prevent accidental engine activation. Subsequently, disconnect the 10P connector from the engine start-stop switch. This step specifically isolates the switch from the vehicle's electrical system, allowing for accurate voltage measurements. The next action involves measuring the voltage between specific test points, the female terminals number 5 and number 1 of the engine start-stop switch connector. This measurement will reveal whether there is battery voltage present. If voltage is detected, it's indicative that the wiring from the switch to the battery supply is functioning correctly, while a lack of voltage will necessitate further inspection of the wiring. Step 3 entails disconnecting the body control module connector C66P to further isolate the circuits involved in the engine start-stop functionality. This allows the technician to check for continuity between the specified test points, female terminals number 6 of the start-stop connector, and body ground, as well as terminal number 10 of the start-stop connector and body ground. Continuity testing is essential for identifying whether there's a short in the SS1 plus and SS2 minus wires. If continuity is confirmed, it suggests there is a short to ground somewhere in the wire, indicating a critical failure that needs immediate repair. If continuity isn't found, this implies that the wires themselves are not shorted, allowing progression to the next step in the diagnosis. In troubleshooting step 4, the technician must connect terminals A and B using a jumper wire to facilitate continuity testing across the engine start-stop switch circuit. Terminal A connects to body control module connector C66P number 63, while terminal B connects to C66P number 5. This setup allows for a check for continuity between the test points when the vehicle is in the off-lock mode. If continuity is confirmed between the engine start-stop connector terminals number 6 and number 10, it means that the SS1 plus and SS2 minus wires are intact. Conversely, if there is no continuity, it indicates there is an open circuit or high resistance within these lines, necessitating repairs to restore proper functionality. During troubleshooting step 5, the focus shifts to evaluating the engine start-stop switch itself. The technician must perform a specific test on the switch to confirm its operational status. If determined that the switch is functioning correctly, the next step would be to replace the body control module, as this unit can affect the overall starting function of the vehicle due to its role in integrating various electronic signals. Conversely, if the switch is found to be faulty, replacing it should be the immediate course of action. The outcome of this step is crucial, as it directly informs whether further intervention on the body control module or just the switch is necessary, thus refining the repair process. The final troubleshooting step for DTC B12C5 involves checking the voltage on the plus B smart line. To do this, measure the voltage at specific test points, female terminals number 5 of the start-stop switch connector and body ground, while the vehicle remains in off-lock mode. This step is essential to determine if battery voltage is reaching the switch. If battery voltage is indeed present, this indicates that there is an open circuit or high resistance somewhere in the ground wire that needs addressing. Conversely, if there is no voltage detected, it signals an issue with the plus B smart wire. Prompt repairs or replacements will be necessary to ensure an uninterrupted electrical supply to the switch, ultimately resolving the DTC. After completing all the troubleshooting steps and necessary repairs for DTC B12C5, it's vital to perform a final verification. This involves rechecking for any DTCs using the Honda Diagnostic System HDS to ensure that the fault codes have been cleared and do not reappear. Following this, the technician should start the engine to confirm that it operates smoothly and that the engine start-stop switch functions as intended. This verification step is crucial to ensure that all repairs have addressed the original issue effectively. Finally, it's important to confirm overall system functionality to ensure that all related components are operating correctly, ensuring the vehicle's reliability and performance. To prevent issues related to DTC B12C5 from arising in the future, engaging in regular maintenance of the vehicle's electrical system is essential. This includes periodic inspections of the engine start-stop switch, as well as the wires and connectors associated with it. Additionally, drivers should remain vigilant for any dashboard warning lights that may signify an electrical malfunction. Proactively replacing components that show signs of aging or wear can help mitigate unexpected failures. Regularly scheduled maintenance checks not only enhance vehicle reliability, but also contribute to prolonging the lifespan of critical systems within the vehicle. In summary, DTC B12C5 indicates a failure of the engine start-stop switch and requires methodical troubleshooting to accurately diagnose the issue. Key steps include checking for battery voltage, verifying continuity, and testing the switch and associated modules. Each step is instrumental in pinpointing the exact cause of the failure, whether it be a faulty switch, wiring issues, or the body control module itself. Moreover, implementing preventive maintenance strategies significantly uplifts vehicle reliability. By following the troubleshooting steps and applying preventive measures, vehicle owners can ensure smoother operation and avoid unexpected shutdowns, making for a safer and more dependable driving experience. Please like and subscribe to the channel. See you next time.